I'm really looking forward to talking about Shiny. It's a tool that I've really enjoyed learning about and using. And I just want to say right now, I'm a NOAA employee, but all of the work and the code that I'm going to show you today is all work that I did as a postdoc at the Ocean Modeling Forum at the University of Washington. We, as fisheries ecologists, work in marine ecosystems where humans are active participants. And human interactions with the marine environment are often modulated by management decisions that are made at a different level. And since time immemorial, we've been using data visualization to communicate about the ecology of certain species. So this is a map that was published in 1892 of the distribution of female fur seals and juvenile fur seals at sea. And we don't know if these two events are directly connected, but 20 years later, they created the first treaty forbidding the take of fur seals in the open ocean, the first international agreement about it. So we've been making these data visualizations, trying to share information about ecology for a long time, and these visualizations and how we communicate them have the potential to maybe influence management decisions if we do them well. So in the title of my talk, I mentioned uncertainty, and that has a really kind of technical definition when you're communicating, model results or estimates of certain parameters. The very basic definition of uncertainty is just that it conveys the degree to which something is known. But I'm going to use it in a little broader sense. All the resources that I share will be useful for any situation where there's something that has a distribution. So for me, that includes simulation outputs and population projections. And uncertainty is a really important part of the scientific process, and how we communicate it is really important too. Previous research has shown that expressing uncertainty as a concrete range of possibilities increases trust in the science, and expressing uncertainty as something unpredictable, impacts that are unpredictable, that can erode trust. So how we communicate uncertainty to people is really important. In my work, and probably in a lot of yours too, the scientific process starts with a lot of ecological data and models that are fit to that data. And the outcome from that process is usually a distribution for a value of interest. In most cases, in my work, that means the abundance of a fish species or a marine mammal stock. So we start out with this probability distribution, and then when we scientists communicate it to management, it is turned into usually a single value. For us, we call these reference points, but it's just a simplification of the broader distribution that we get from our scientific process. And so if that single value, that reference point, is used in management, that feeds back into the natural ecosystem, and we kind of have this loop of the scientific process and how it fits into management. So this step, how we convert this distribution into a single value, or how we communicate that to managers so they can get a single value from it. This is a really important process. So I can't emphasize enough like how much uncertainty plays into how we communicate and how important it is to do it properly. And one main reason for that is that in many countries, we have a mandate to manage our natural resources in a precautionary way. That is to take not the riskiest approach, usually a risk-averse approach. The other reason that it's really important is to maintain confidence in the science. That's among managers and also in the public. And then finally, we really want to be able to communicate risk levels accurately, because those are an important part of management decision-making. So luckily for us, scientists and developers alike, we have all these amazing tools in R that we can use to do this communication step. We have reports from Markdown that are, they can be websites, they can be HTMLs or PDFs. We've got dashboards to convey large amounts of information in a simplified framework. We also have tools that react to user inputs. So Josh mentioned earlier, one of the later talks in the series is going to be about Leaflet. This is great for showing interactive maps, allowing people to kind of zoom in and out and explore data on their own. And what I hope to convince you of today is that Shiny has all of these features kind of packed into one tool. And that is because it can both display information in kind of a report looking format, and it can also execute code based on user actions. So it can be this really powerful interactive communication tool. So I'll start with an introduction to the app that I developed during my postdoc. This is the Marine Mammal Bycatch Impacts Exploration Tool. Then I will share some code with visual tools for communicating uncertainty in R with a little demo. We'll talk about using Shiny to make simulation outputs more comprehensible for people. And then I'll share some of the struggles that I experienced while developing my Shiny app and the gems of wisdom that came out of that. And if there's time, a short demo of some features that I think are important to do if you're a developer. So let's dive into this app. So this is the system, this is the type of system where I work in fisheries. When fishermen go out and catch wild fish, they are operating in a complex marine ecosystem. And this is an image that I like to show that kind of illustrates that. This is, I think, a crab vessel in the Bering Sea. They're sorting the catch on the deck, but you can see in the background, there's this dynamic marine environment. There are all these bird predators kind of waiting around, hoping for a snack. So some interaction between what the fishermen are doing and what the rest of the ecosystem is doing is sort of inevitable. And one of those big interactions that we're concerned with in management is bycatch. This is the unintended catch of non-target species. So the technical definition is discarded catch of marine species or unobserved mortality that's due to a direct encounter with fishing vessels and gear. And this image on the right is sort of an artistic representation of all the things that you might catch in a bottom trawl that is targeting just one species of groundfish. You get all of these other things. And marine mammals are no exception to that. So marine mammal bycatch includes any interaction with fishing gear, even if the marine mammal doesn't die from the interaction. So for example, this California sea lion, actually, I don't know if this is California. This is a sea lion kind of getting dumped out of a purse seine, and you can see they spray him with water to try to get him to go off the side. So that mammal may survive and be fine, but this still counts as a bycatch interaction. Other bycatch interactions include things like entanglements. So this humpback whale in the top right has been entangled in a crab pot line. And sometimes these interactions don't immediately cause mortality, but they may impact things like their breeding or their ability to feed. And then, of course, they can just get caught and die in the fishing gear. And this is a huge management concern for marine mammals specifically because bycatch is one of the biggest threats to their populations worldwide. In the US, we have a specific approach to how to manage marine mammal bycatch. The piece of legislation that governs marine mammals and their conservation in the US is the Marine Mammal Protection Act. And it includes guidance about how many individual marine mammals from a given stock can be killed by accident in a fishery before it starts to negatively impact the productivity of the population. Ideally, there would be no interactions with the fishery, but there are going to be some of them. So the MMPA includes this guidance about how many can be killed before that is going to be an issue at the population level. So that value is a reference point called potential biological removal. I will call it PBR because it's easier to say throughout the talk, but this is the one acronym you have to remember. So the PBR approach, the PBR approach involves this fairly simple equation. The equation for the reference point is this value n min times 0.5 R max times FR. N min is the 20th quantile of the distribution that describes the abundance estimate. R max is a value that is intrinsic to that marine mammal stock, and it has to do with how fast their population can grow when they're not facing sources of human mortality. And then finally, this FR value is called a recovery factor, and this is decided by management based on the status of the stock. So for a endangered species, it is a lot lower than something that is considered to be a good stock status. And this approach to managing bycatch for marine mammal populations has largely been a success in the US. Since the implementation of the MMPA, we've had recovery of a lot of marine mammal stocks, and it seems to be working fairly well, and it's a good kind of risk-averse approach for managing bycatch. But the tricky thing about this approach is that it requires a lot of data, and it requires advanced assessment models so that you can get that estimate of abundance, so you can get your N min value and figure out what that reference point is going to be. So our challenge in the Marine Mammal Bycatch Working Group at the Ocean Modeling Forum was to make the PBR approach and similar risk-averse approaches accessible to managers and stakeholders in places with less data or no population model. Despite the image of marine mammals as this iconic group of marine species, there are actually quite a few marine mammal stocks that are still very data poor. So our task was to build a toolbox of tools that people could use in places where maybe they don't have enough resources to do a full survey, or they don't have a stock assessment team doing their marine mammal assessments. My contribution to this was the Marine Mammal Bycatch Impacts Exploration tool. So this is an online app. The most kind of basic thing that it does is based on some very simple life history traits about a marine species of interest and some information about stock status and a range of potential realistic bycatch levels. Users can explore the long-term impacts of those bycatch levels on the population. And the thing that is useful about this is that it shows long-term impacts. So it's hard sometimes when you have very little data to understand what's going to happen, 20, 30 years in the future. But these long-term projections are what the PBR approach is based on. So at a very sort of simple level, this is what it does: population projections, and people can look at the outcomes over time. Behind the scenes in the app is a simple age-structured model where calf survival, adult survival, and reproductive parameters are dictated by that life history type that the user has chosen. On the age 1 and older individuals of the population, in addition to natural mortality, there's this additional bycatch mortality, and that's dictated by the bycatch levels that the user has chosen to explore. So I'm going to switch over to what the app looks like in real life. So I showed you the sort of simple option. There is also a more advanced option for users who have their own parameter estimates for juvenile survival, adult survival, and age at maturity and population growth rate. They can put in a value of uncertainty for their estimate of abundance. And they can also look at a bunch of other outcomes from those projections. So up here, this is just a ribbon plot showing the abundance projections over time for the range of bycatch levels that they chose. They can look at the long-term outcomes in a bunch of different formats. One is just a regular kind of performance table. This little kite plot is showing kind of trade-offs between different objectives. And then we have these violin plots that are kind of showing the distribution of abundance values amongst those projections. several years after the projections start. They also get a little table that includes values that they need to calculate that PBR reference point to give some indication of what that number of individuals might be. There is also a PBR calculator. It really just calculates this equation, but it shows them kind of where those values come from. It explains the PBR approach, and they can put in values that they got from the other tab and get a PBR estimate. If they want to, they can generate an HTML report. So this is just a report showing what inputs they put in and some of the long-term performance of those bycatch ranges, and then a list of the reference points. Oops. Then finally, the documentation for the model is built in. So if they want to read about the model, they can look at the sort of model structure, where the parameter values come from, citations for everything. They can also look at an interactive plot of parameter estimates for pinnipeds and get citations for those as well, if they want to use them for their own projections. It's also live translated into Spanish and French in case users want, in case that's their first language. And I don't know why it's not going. Well, we'll try it again. It has this live translation feature because we have a lot of potential users who are in countries where this is, English is not their first language. Is that? Is everybody still there?
Yes, we're still here.
Okay. It got very quiet and my browser isn't reloading, so I thought maybe that isn't, I don't know. Maybe it's the Shiny server. Well, I'll show you in a couple of minutes if it doesn't come up. Anyways, just when you click on these different buttons, the whole screen translates into a different language and explains everything in that language. So that's for people who speak other languages. Okay, so the app is also embedded in this R package called mmrefpoints. And that is primarily so that people who don't have a stable internet connection can download the package and run the app locally. So they don't have to have a browser with a stable internet connection to access it. But it can also be useful for people who are interested in using the models that are embedded in the app. So it contains all the functions that are used to do those population projections. So here are some of the tools that I thought were really helpful in this, like writing this app and communicating about it for displaying uncertainty in a single value or a single variable, to communicate it with a broad audience. So in the app, you saw violin plots, and these are essentially just plots of a distribution, but they're mirrored across an axis. So sometimes it's easier to see the density that way. I've used these in the app itself, but I actually think that the gold standard for showing distributions are rain cloud plots. And these show the density. They also show the scatter of points in the scatter of different values for a single value of interest. In this example, it's just body mass for penguins. And they show kind of the standard box plot if that is what people want to see. And we'll have demo code for these in a second. I also had to show a single value or variable over time, and the two ways to show that I think worked the best were ribbon plots. So this plot on the left is showing the 50th and 95th quantiles for population projections into the future. And then on the right, there are what we call spaghetti plots that show individual trajectories of each simulation over time. And those spaghetti plots are important when you have some kind of time series to show, because it's a good way to communicate the amount of variation that you could have in a single simulation. And I think an important element to communicate always with time series is that the central tendency doesn't necessarily describe the majority of the simulations. Sometimes, especially in the field that I work in, which is fisheries management, where we are doing a lot of simulations to try to communicate ideas to stakeholders, you have two or more values or variables that you want to show at the same time. One popular way to do that is through kite plots or spider plots. Another is traffic light plots that I'll show you in a second. And then the third is decision tables, which are kind of a new type of table on the scene. So the way that kite plots work is that you can imagine it kind of like a wheel. The spokes of the wheel are different performance measures that are based on performance goals or management goals. The center is 0 and the outside is 1. So usually when these are displayed, the further a point is out on that circle, the better the performance is. So for example, here's one scenario. The scenario could be, a management decision or a harvest control rule or the implementation of something. And it's performing less well on this axis over here, but it's performing, reasonably well around the outside compared to the other scenario. So you can also overplot them and kind of look at differences in performance across multiple performance objectives. So another option for sharing some of these types of results, and I have seen people use these for stakeholder management a lot, or communicating to stakeholders and managers a lot. And these are called stoplight tables. This is sort of a simplification of a lot of simulation outcomes. So in this example, along the left, the rows are indicators or performance outcomes. So this might be like long-term average biomass or long-term average abundance. For us, it's also something like catch stability for the fishery. And then columns are different management options that they could take. And they're color-coded by the relative performance of those management options based on the different indicators. One that I have seen recently and think is a great way to communicate the sort of vast amount of information you can have when you do a simulation study are called decision tables. Amanda Hart at UMass Dartmouth came up with a package that makes these, and I have a reference to it later in the slides so you can use it. But these allow kind of an additional dimension of data visualization. They have the height of the bar can also mean something. So in this toy example, the height of the bar indicates the absolute performance of that indicator. The color of the bar indicates its rank compared to the other members of the row. And that kind of allows you to communicate one extra dimension of data. So this data visualization shows up in the Northeast Fisheries Science Center Atlantic Herring Fishery Management Plan, and there's a R package about it. So those are just a couple kind of popular data viz options for explaining uncertainty and communicating large volumes of simulation results. But I also think that Shiny can help us communicate uncertainty and build trust with our audience if we do it properly. So my first kind of soapbox talking point always is that building a Shiny app for your system and for stakeholders or a specific audience that you're interested in reaching can really teach you a lot about your own data and models. You have to learn about the limitations of certain parameters. You have to learn about how other people see the system. It's just a really good practice to go through in order to better understand your own work. Furthermore, I think having a reactive interface like Shiny can help users understand the system too. So when they can explore parameter space, that helps them better understand sources of variation in the system and what the outcomes are when there's a lot of uncertainty in some of those parameters. It also helps people explore model outputs. And I think this is really important because not everybody is going to want to or have the time to dig into the nitty-gritty of how every single model works, especially when people are, when they are not modelers for their full-time job and they're doing other things, but they still need to have an understanding of how a model behaves. Exploring the different outputs can give them kind of like an overall instinct for how the models behave. And I would argue that this builds trust in the models. If people can see what's happening behind the scenes and kind of tinker around and explore what the model does in different situations, they tend to feel more comfortable with the model and see it less as a black box. And I think this is like a really important thing that I hope we can bring to other kind of natural resource management situations and science communication in general. I think it's also nice to have an interactive interface for having people who are accessing information from different places or different kind of specific interests. So in my Shiny app, I learned that a lot of users don't necessarily want all of the details right up front. It can be overwhelming, or if that's not the detail you're interested in, it's just not relevant to your interests. So I think having an interactive interface allows you to kind of hide the details until people want them, and sort of reveal them as they're needed. Okay, so now I'm gonna switch over to a really simple demo app for making those data visualizations. And if you want to follow along, I believe Josh has put this code on the EFI GitHub page, and it's also on my GitHub page. The code is the same, so if you can access it either way, and you can clone this whole directory, and it's all project based. You don't have to change anything in it; just run it. This just has a couple demos of different options for showing uncertainty in one or two variables. Oops, okay. Go back here. Okay, so if you're in the SciPL EFI directory that you've downloaded, you can go into this dist app folder. And if you click on app.r, this is the code for the example app that I have. And if you click run, it will show this really simple app for showing, this is using the Palmer penguins data set, and it's showing the distribution of individual body mass by sex and by island. Up here, this is called a select eyes input, where you can pick different options. So now it's showing that output from 2 islands. So the first tab is a rain cloud plot. The second is a violin plot showing those same distributions. And then the third is a kite plot. It looks a little bit weird because these are not really parameters that are supposed to be displayed on a kite plot. They're just bill length and depth and flipper length. But this is what kite plots look like, and I included some code for generating one of these if you need to communicate trade-offs in your research. So that is what the app looks like. You can add, I think there's three total islands. So these are all the options highlighted at once. Okay, I'm going to close that and just show the code really quickly. So these are all the packages that get used. All of this stuff, that's all for the data visualizations. So if you want to just use that plot code for something else, those are the packages you need. The half violin plots that I used for the rain cloud come from a specific GitHub code snippet. I'm sure there's a more graceful way to get these, but this is how I do it because I like to do things quickly. So that's just a code snippet that has that specific code in it. There's also the Ghibli and HRBR themes packages, and these have different color palettes and themes in them. I don't know if this is really necessarily always recommended, but you can set the theme and palettes and stuff outside of all of your Shiny server functions, and then they're accessible globally throughout the app. What I have found is that I usually want different themes or different kind of graphic specifications for different pages in the app. So I don't usually do this, but you can do it if you're making a really simple tool. So this is what all the code looks like. This is just the single user input, the different choices they can pick. And then I have this text output here. That's the number of islands selected. And it's just so I can show you an example later about testing. And then this is really like the whole interface of the app is just this, the UI section, but really like the main pages are all just here. There's 3 tab panels and they each have a plot in them. And then down here, this is like, if I were making this more polished, I would turn each of these, the contents of these output objects into functions so that there wouldn't be ggplot code in the app.r file. And that's just because things get messy really quickly in Shiny. But I made it messy because I was trying to make it, compact, it's all in one file, and, the simplest version. I think when people start developing Shiny apps, a lot of the time it's just easier to understand when everything's in the same file, and then later you can worry about polishing it up and putting everything in the perfect spot. So what else do I want to show? That's all I wanted to show for that example. So those are the 3 kind of main like communication methods that I've found the most useful in talking about simulation outputs and trade-offs with people. I also have, I guess I took it out of here, but it's later in the slides. I have a reference to Amanda Hart's package for making those decision tables too. Okay, so now I'm going to share some of the struggles that I faced in developing this app, and you may still have the same struggles. I am not promising that I will make it, a smooth ride forever, but hopefully sharing some of these will make you feel some solidarity and also give some tools for dealing with them. So the first struggle that I faced when I was developing this Shiny app and others is that you spend all this time learning how to use this amazing tool. It's so cool. It can do all this different stuff. And sometimes it just isn't, when you have a shiny hammer, everything looks like a nail. And sometimes Shiny isn't necessarily the tool that you need. So these are a bunch of things that Shiny is not really quite built to do yet. Storing a bunch of data, storing information about how people use the app, what they click on, how long they spend on the site, where the traffic is coming from on your server, authentication, really fancy websites that have a lot of bells and whistles and different features. Like Shiny can do these things, but right now it's not exactly built to do them. So learning that was like a little bit of a struggle because I wanted to believe that Shiny could solve all of our problems. The other struggle, and I guess this is kind of an ongoing struggle, but kind of a joyful one, is the concept of the user experience. So to illustrate this, I'm sharing this cheesy quote, famous quote from Spider-Man, which is, "With great power, there must also come great responsibility." So when your power is Shiny and Shiny developing, your great responsibility is that your users have an enjoyable experience that they know how to use the tool that you've made, and that they are using the tool the way that it should be used. So here are a couple little tidbits from that user experience journey that I went on. The first is that it's super important to define the user goals. So sometimes this is a collective effort between you, the developer, and your audience. For me, it certainly was. I needed to know what they needed. And we sort of came up with a list of goals together, and that kind of completely changed how I saw the app that I made. Another interesting thing that I learned when I was kind of writing the questions to ask people during pilot testing sessions. I had 2 pilot testing sessions, and they were both remote. And I had first come up with a list of questions, and I asked a bunch of questions like, how, on a scale of 1 to 10, how easy is it to do X? And I talked to some of my friends who are user experience experts, and they were like, you have to read all this literature. This is a whole field and you're doing it wrong. So I went back and read a bunch of things. And one of the interesting things that I learned was that you can guide people to give you the information that you need from them when you ask the right questions. So one of those is to use missions to discover how people use the app. So for example, you give them a task to do with the app, and you just sit back and watch how they do it, or you can ask them how they did it. I thought that was a really enlightening kind of like change of perspective. There are also some online tools. So for other apps, there are these online places, applications like Maze and Usability Hub, and those allow you to test how users are interacting with software, and you can kind of ask them questions simultaneously about how they're using it. I didn't actually end up using either of these interfaces, but they are available as a resource. So another is that there are all these online examples of survey questions that you can ask people when they're pilot testing. So here's a link to 18F Methods, which I think has a great kind of comprehensive list of the types of questions you can ask people. But there is just so much guidance out there already on how to describe and understand user experience, and using the resources that are already out there will only make your app better and more usable. Okay, this is sort of a second demonstration based on a struggle that I am still currently embedded in. And that is, how do you write a good test for a Shiny app? If you are writing a Shiny app that's part of an R package, or if you're writing sort of a production grade Shiny app because you work in industry, or you're going to make a management tool that's going to be hosted on the server of the agency that you work for, it's really important to write tests and to run through those tests regularly. And this is something this is a concept that I'm used to from R package developing, but it matters for Shiny apps too. And it can actually, I think, get hairier faster in Shiny world, because the Shiny code is like more complex than, standard R code. So I'm just going to show a really basic example of what a Shiny test looks like, and then a little bit of guidance on how to start writing tests for your Shiny app. I should also mention, this is also really helpful if you are working on an app with a team. If you're not the only developer, you may want to use continuous integration to test your software as you're developing it. And when you write good tests, you can use GitHub Actions or whatever other kind of continuous integration tools you have to run those tests every time a commit is made. So one person doing some small thing doesn't break the entire app. As you probably know from using Shiny, sometimes if you do the wrong thing, that window doesn't even come up to show you what the app looks like. So you're kind of stuck wondering like, okay, it broke, but where? So here is just a really simple example of what a test for a Shiny app looks like. So in this same directory that the app is in, there is a tests folder, and just like an R package, there's a test.that.r file. This looks a little bit different because it's tests for a Shiny app. So this is this little line, this env thing, creates a new environment that sources all the files that are used by the Shiny app, and that helps test all the different elements individually. So then in the test that folder, right now I only put one test in here, but this is a server test. And it's, oh, I'm gonna go back. First, I'm gonna show you what the code looks like kind of in more detail for what is happening inside the tests. So this is just kind of a written out version of what the test is doing. So test server is a Shiny specific testing function. And for this one, I just wrote it so that it would print out the outcomes from the test. If you were to run if you were to run that like test server.r, it would not show you anything in the console. So you wouldn't necessarily like be able to check that it is doing what you think it's doing. So here inside the test server function, you can set inputs. So for example, if I want to know, if a user chooses to see Torgerson Island, what is going to happen? And this is kind of a cheesy example, but like that num selected value that I showed you in the app, it's like a little text that prints. I'll show it to you again. So num selected is just a little value that shows up here underneath what islands they're showing, this number of islands selected thing. So this is num selected right here. So in this test example, we're just saying set the, like, pretend the user has put in Torgerson as the one island that they want to look at, and print out what num selected says. Then set it to 2 islands and print out what that num selected value says. So we expect if they select 1 island, it should say 1. If they select 2 islands, it should say 2. So if we run that function, it'll print out, this is what num selected is when only Torgerson is highlighted, and then when there's 2 islands highlighted, num selected is 2. So that num selected value is working the way that we want it to. So that is just like a version of the test that prints everything out so you can see it. But when you're actually writing your tests for like long-term checking and you want to use test that, the tests, that same test would look like this. So it's the same test server function. You give it the server object, and then you set the inputs to these 2 islands, and you use that same test that function, expect equal, that you would use if you were writing an R package. So so that is, that's what the sort of test that directory looks like. It just has this one test in it. And then when I do Shiny run tests dist app, it will run all of the tests that are in that folder. It looks for the test that directory. It runs them all just like it would if you were using DevTools and developing a package. And it told me that it passed that one test. So that is like very simple, but it's just an example of what these tests look like. And my moment of vulnerability, because I believe that vulnerability is important when teaching and communicating, is that when I started writing my app, I didn't write a single test. So I had to go back and write them all. And I'm still working on writing them. There's also some recommended tests that have already been kind of developed for like standard Shiny apps, like does it run, etc. And I'll show resources for those at the end. But I think, as you know, for testing R packages, tests or for developing R packages, they're really important. And for Shiny apps, they're important too. And I hope that people use them so that they can avoid later heartbreak when a user tells them that something is broken, or their situation doesn't work in the app because something has failed. So that's kind of a struggle that's ongoing. A gem of wisdom that I came across in this development experience was that accessibility is really important, and there's already a lot of resources out there for making your app accessible to people who might have visual difficulties, or people who are colorblind, or people who use screen readers. If you want a wide audience for your app, that includes people who read web pages in a different way than others, and you want to make sure that your app is usable for those people as well. So there are all kinds of tools out there. There are emulators. So there's some, I think Google Chrome has a built-in thing that will let you emulate certain vision differences. There are also automated tools. There's a whole list in this article that I have a screenshot here by Kelly Hundula. There's she has a whole list of different tools that you can use, including some automated places where you just give the URL of your page and it checks through your page and tells you how accessible it is. And then there are also kind of standard checklists. So this is from NOAA. This is the Section 508 compliance list. And they have a whole list of things that you should include in your app to make it more accessible. So my take-home messages, I think any developing project is like a lifelong learning experience. So these are by no means my final take-home messages, and I am certainly not an expert in Shiny app development. But the things that I learned that I hope you can appreciate later, or that might resonate with you, are first, that developing an app can help you understand your system and your audience better. Sometimes it can feel like you're spending a lot of time making this fancy thing, and you're like, is anyone gonna use my fancy thing? Is this worth it? Should I even be doing this? Is this a fad? And I would argue that even if no one uses your app, developing it and talking to people about it and sharing it with your audience can help you understand your own system, your models, your data, and the people that you're working with better. And that is always a valuable experience. Another take-home message that I really appreciated, I think this was in last week's Absalon seminar on Shiny development. Someone, I can't remember who said this, but it was so, I liked it so much. And that is that it's so tempting to help people use your app. And they said, don't help people use your app. You have to encourage them to explore. The app should sort of stand on itself as, it's to stand on its own as a tool that they can have their own relationship with. The third, and this is something I will take home as well, is that you should use modules and test them and write good tests. Writing good tests is kind of like, I feel like it's a little bit like paint a beautiful picture. And you're like, yes, I know I should do that, but how? So I think writing good tests is also an interactive, experience that you have with if people tell you something breaks, like write a test about it. If someone submits a GitHub issue, write a test that checks that issue to make sure that it doesn't happen in the future. And you can also, like for my tests, I got some of them from communicating with my postdoc advisor, who understood the population dynamics model really well. So communicating with the people who know the code the best is really useful. And also, finally, accessibility is really important, and it's also kind of a fun experience when you're designing something. With that, thank you everyone for being here. Thank you for inviting me. And I'd love to have further discussion about any of the things that I talked about previously, or anything Shiny related. I have some other Shiny code and slides and tutorials if anyone wants to kind of try out code and do some examples on their own. This link at the bottom, mcSiple/Shiny overview, has some bare bones, basics, shiny stuff. It has a leaflet example. It has a live example for live translating your app using Shiny i18n. And there's a LearnR tutorial on there too. So there's all kinds of stuff there if you're interested in those. And I love to take questions and further discuss with everybody.
Thank you.
Great, thanks, Margaret. So I'll refer to that poll everywhere page for questions that I have that have been posted so far. So kind of going off the top voted ones to start, have you gotten much feedback from managers and stakeholders? How did the people who would find your app useful find your app?
Great question. I have gotten a lot of feedback from stakeholders. So I had 2 official pilot testing phases. The first one was before both of those, I had a testing phase where it was just marine mammal scientists. And they had lots of suggestions and great recommendations for things. And then I went through my first pilot testing phase and all the stakeholders were like, what is this? We don't know what this is. Like, we don't know what these values are. What do you mean by CV? What is all of this? So after that phase, I ended up simplifying the interface a lot more and showing less right off the bat. And then I also included tooltips to explain certain things. So if you hover over a term or something, it will give you a definition. That's also the phase where I started trying to look into translation and how to turn the app into French and Spanish versions. And then I had a second pilot testing phase, and that one had an even more diverse audience. So there were lawyers, there were marine mammal kind of management folks, and then also scientists. There were people from NGOs who work on marine mammal bycatch. And they had a whole another set of questions and recommendations. And what I got from that was not only a few modifications to the app, but also some information about how I should kind of roll it out, how I should present it to people. So I decided after that phase, like I should have some kind of workshops and tutorials to show people kind of how to use it. Try not to show them too much how to use it, but just interact with people who are using the app regularly and show them some demos of like a really simple situation where, you know, you have a data poor fishery, data poor bycatch situation, and, you know, it's a dolphin and you need a value of PBR for a management need. So I got different things from each of the pilot testing phases, and I can't say that every single person is happy now. And I just have to be at peace with that. But like the goal isn't for everyone to be happy, it's for the most people to be able to use it who need it. So I think we're getting there.
Okay, great. The next one is, do you have any references for best practices on writing tests, either in general or for Shiny apps specifically?
Yes, and I'm always collecting them also. Writing tests is really hard, and people they tend to just say, do it and make them good. It's like, what do you mean? I have some at the in the additional resources section of these slides. I have some links to pages that I've used. Let's see, so the sort of basic Hadley Wickham's Shiny development book is what I kind of use as like my baseline reference, but the Shiny testing resources there are like not slightly outdated, but they're just like a little bit older than the ones on the RStudio website. So I encourage people to look at, I think it's shiny.rstudio.com. They have a whole list of testing resources, and they also have like guidance on setting up your file structure for an app, things like that. Also, if you use Golem, so if you're putting your Shiny app in a package, the Golem package is developed specifically for doing that. And that will also, they have some suggested tests in there, and their documentation has some advice on writing tests.
Okay. Next is Shiny has a pretty steep learning curve. What recommendations do you have for people who want to implement Shiny, but the learning of Shiny apps is not a primary focus of your project or research?
Yeah. I don't have great advice for that part, I don't think. I would say start as simple as you possibly can and try to weave it into some other part of your work. So I really like when people who are presenting something have a little accessory Shiny app to show maybe different examples or different scenarios, or when people are teaching, when professors use Shiny to show model behavior. They're all kind of little ways that you can work Shiny into some other part of your work. But there isn't really a great way of getting around the steep learning curve part. It's kind of just, you just get on the curve and see where it takes you. But I don't think any of that time can be wasted, because you're learning how HTML works, honestly, because all Shiny functions are writing HTML code. So that is a tool that you can use in so many different situations, everywhere, in every field. And you're also just like keeping your programming brain alive, and that is always a good thing. So it may feel like drudgery when you're on the steep part of the learning curve, but it gets better, and when you're learning, you're doing good things for your future.
Okay, great. Another question asks if there's any suggestion for working with large data. Is it only about processing time as an issue for Shiny, or do you think using a data storing platform outside of Shiny would be a better approach, essentially?
Yeah, that's a great question. A lot of people have this issue with the volume of data that they want to show. I have seen people make apps that retrieve data from a database that's remotely located. They're not fast. So I think the ones that work the best usually retrieve the chunk of data that the user needs and store it locally temporarily. And then they can play around with it, whatever, and then they can do another query. So that is like, I didn't have to do this for my project, so it's possible that there's a much better way to do it. But what I've seen other people do is set it up so that there's kind of like a reactive object that's all of the data that they need, and then they can mess around with it, whatever, and then do another data retrieval when they need it. So they only have to wait once. But it is tricky. That's like, Shiny is not super fast, and interfacing with remote, like you doing SQL queries and stuff, it's just, it works, but it's not fast yet.
Okay, thanks. Another person asks, it sounds like the language translation for the app is done automatically. I assume this is an option when setting up the app. Have you had native speakers assess how well the translation does?
Yes. Okay, so there's two options when you're translating. If you have, if you're looking at your web page, there are page translators that will translate any page. Like when you go to a page that's in a different language on Google Chrome and it says, do you want to translate this? Like, that is one translator. What we did, and maybe I can share my screen and show this, what we did in our app was to have native speakers and scientists from those countries proofread the translation. So our Spanish speaking marine mammal expert read all of the translations and improved them. I did some of the translation like myself, trying to do a good job. And we also had people who were paid translators translate some stuff. And then later we had a scientist proofread all of them for each language. So this is kind of, can everybody see this? Maybe we should zoom in a little bit. Okay. Check that out. So when you have this live translation feature, the server code has these shiny 18N features in it. So this observe event thing is just updating the selected language, and then shiny I18N uses a JSON file that's stored in the app directory to look up the translation for specific phrases. So you'll see down here, this is like, there's a good example. This code is, still so complicated. Oh my gosh, here we go. Okay, so here's just an example. The phrases that are getting translated are wrapped in this I18N $T for translate function. So I18N is literally going into a directory. It looks in that JSON file for something that says marine mammal life history type, choose one, and then it looks up what we have said the Spanish translation of that is. So it's not like kind of a free form, like, Google Translate type thing. It's like specific phrases that we've picked. And that took a long time. So I definitely encourage people to do it, but I also understand if people don't do it. It takes a while. And it does make the code look a little bit clunky because there's a lot more parentheses. So that's how we did the translation.
Okay, cool. Another question asked, what was the package from the developer at UMass?
Oh, it's called Decision Table. I will just paste it in the chat in case it's like not in the notes where I think it is. There's the link to it. So, oops, I just sent that to only a single person. Everyone in meeting. Okay, so that's the Decision Table site. It's not on CRAN or anything yet, but Amanda tested it out with managers at the Northeast Center and found that it was really helpful for communicating really complex simulation results to them.
Great. Another question is, were you asked by stakeholders to produce an app for communicating your research, or did you decide to make one and then reach out to stakeholders afterwards?
We planned to make one from the beginning, but we checked with some stakeholders before I actually started writing code to make sure that people needed it. We worked with the project was funded by the Lenfest Ocean Program that already has kind of a long roster of scientists and people in conservation and management that they are in touch with. So they helped us also figure that out when we first started the project. They were like, look, one thing you might have to develop is a software tool. Can you do it? And we said yes. So that was kind of facilitated by the Lenfest Ocean Program. But we also had meetings, like I went to a couple scientific meetings about bycatch at the very beginning of the project and talked to people early. We also had people from countries, this is probably more information than everyone needs, but one of the reasons that people need this tool is that the US recently passed, or not recently anymore, in 2017 passed a new seafood import rule with a 5-year grace period to 2022, saying that countries that export seafood to the US need to have marine mammal protections against bycatch that are comparable in effectiveness to those of the US. And so this is like a concern for foreign governments who are exporting seafood to the US, they need to make sure that they're managing bycatch in a way that is compliant with that order. So that was kind of the motivation behind making an actual tool for them. I didn't share that in the presentation because it's just like a lot of legal details, but that was the kind of like motivating force. And we had a couple people who were from those countries in our working group, like scientists from those countries, so they could show us, you know, this is what we have to provide to the US, to NIMFs, in order to apply for this comparability finding. So we could kind of see what they needed.
Okay, cool. I think there's a few more questions left. So another asks if you can give an example of something you changed in your app to improve accessibility.
Can you read that again? Sorry.
Yeah. Can you give an example of something you changed in your app to improve accessibility?
Yes. We had one of the biggest accessibility things that I had to change was making sure that color was not the only indicator for a graphic. So making sure that things are labeled and in an order that helps people read it, even if they aren't distinguishing between, you know, red and green or whatever. Like originally I had red and green as the two bookends of my bycatch levels, and all the scientists hated it anyways, so it wasn't hard to get rid of. They were like, that means that red is bad, and it may not be necessarily bad. So I was going to get rid of it anyway, but having, in general, having like figures that you can interpret without seeing them in color was one big change that I had to make across everything. Yeah, also making things flow from top to bottom and not making people look at two columns at the same time. That was a big one.
Another question is just asking about Epsilon and like what that is essentially, since you mentioned it before.
I honestly, this is a question that I have as well. I don't really know what Epsilon is. I think it's a company and they make products for Shiny developers. Like they develop packages and do other things for developers. But honestly, I don't know. I don't really know what Epsilon is. I just use their resources and I go to their online seminars, and they're great. So I highly recommend, even though I am ignorant of what exactly they are and what their mission is.
Okay, yeah, that's kind of the sense I've gotten from just what I've seen. Another question is, when you present the uncertainties in your model predictions, you get a sense that users believe your predictions too much, ignoring the uncertainty arising from different factors that your model ignores. So things dealing with assumptions.
Yeah, totally. So, and this is the thing, this is like a simulation struggle forever. And that is, if you include all of the realistic sources of uncertainty in a projection, you don't get anything out of it because your confidence intervals are so wide that anything is possible, essentially. So we had kind of a discussion with the modelers and the other marine mammal scientists at the beginning of the model development part. And we agreed that the most important sources of uncertainty for these projections were uncertainty in the abundance estimate and variation in bycatch over time. And the way, you know, a lot of people have requested things like, how can I include environmental variation in this? If I'm a marine mammal manager and I'm interested in, you know, humpbacks moving based on climate change, like how do I incorporate that in these projections? And that is, including that specific source of variation is something you can do fairly easily in the R package. And in the app, we just wanted to be able to show people the most important sources of uncertainty. So that's why the confidence intervals are, they're smaller than like you might expect based on natural variability. That said, we have tried to make part of our rollout communication process. This tool is only as good as what goes into it. So if you don't have a lot of confidence in your abundance estimate, it's going to give you a low estimate of PBR, because that's how the framework works. That's how like the modeling framework works. And it's the same in the US. When we have a data poor population, we have to estimate PBR. Like that, the same thing happens. Like you go to the lower 20th quantile, and that's your risk averse approach, because that's what works. But yeah, we have, that was also the reason that we made that printout report, so that if people, if managers want to use this app as part of a comparability finding that they submit to NIMFs, that somebody on the other end can see what they put in. So they, you can't say like, look, I made it work because I, tuned the bycatch level way down. Able be below or level that's actually realistic for my system. Like the people who are reading the results can see what they put into the app. So it's a fully kind of transparent process. But yeah, that's kind of a struggle when you're writing models and communicating them too. It's like, what do you do with all these different sources of uncertainty?
Okay, great. And the last, at least written question, is asking if you've tried the Shiny test package.
I have, yeah. So that is, I should have said that in the testing part. So there is the Shiny tests package, I believe came out before Shiny had all of that testing apparatus like embedded in Shiny. I think it's Shiny 150. They included all of this testing, all these testing functions. And previously those were only available in Shiny tests. So I think now you can do all of your testing not having to use Shiny tests, but you can if you want to. It's not like obsolete, it's just different tools for doing the same thing. That's my understanding. Right now I'm using just the Shiny functions, and then I use test that like everybody else.